Hello. So I'm going to be reading The Metamorphosis of Plants. Okay. Let me start. This is by Johann Wolfgang von Goethe. Sorry, look. I'm going to take somewhat of a more paced approach. Uh, Feel free to pause the video, save the video, come back, and whatnot. So the book begins with a poem. Yes, I'm going to begin. The Metamorphosis of Plants. Goethe poem. The rich profusion thee confounds, my love, of flowers, spread athwart the garden. Aye, name upon name assails thy ears, and each more barbarous sounding than the one before, like unto each the form, yet none alike. And so the choir hints a secret law, a sacred mystery. Ah, love, could I vouchsafe in sweet facility a simple answer, gaze on them as they grow, see how the plant burgeons by stages into flower and fruit, bursts from the seed so soon as fertile earth sends it to life from her sweet bosom, and commends the unfolding of the delicate leaf to the sacred goad of ever-moving light. Asleep within the seed the power lies, foreshadowed pattern, folded in the shell, root, leaf, and germ, pale and half-formed. The numb of tranquil life, kept safe and dry, swells upward, trusting to the gentle dew, soaring apace from out the enfolding night, artless, the shape that first bursts into light. The plant child, like unto the human kind, sends forth its rising shoot that gathers limb to limb, itself repeating, recreating in infinite variety. 'Tis plain to see each leaf elaborates the last, serrated margins, scalloped fingers, spikes that rested, webbed within another organ, at length attaining preordained fulfillment. Oft the beholder marvels at the wealth of shape and structure shown in succulent surface, the infinite freedom of the growing leaf. Yet nature bids a halt, her mighty hands gently directing even higher perfection, narrow the vessels, moderate the sap, and soon the form exhibits subtle change, the spreading fringes quietly withdrawn, letting the leafless stalk rise up alone, more delicate, the stem that carries now a wondrous growth. Enchanted is the eye, in careful number or in wild profusion. Lesser leaf brethren circle here the core. The crowded guardian chalice clasps the stem, soon to release the blazing topmost crown. So nature glories in her highest growth, showing her endless forms in orderly array. None but must marvel at the blossom stirs above the slender framework of its leaves. Yet is this splendor but the heralding of new creation, as the many-hued petals now feel God's hand and swiftly shrink. Twin forms spring forth, most delicate, destined for union. In intimacy they stand, the tender pears displayed about the consecrated altar, while hymen hovers above. A swooning scent pervades the air, its savor carrying life deep in the bosom of the swelling fruit. A germ begins to burgeon here and there, as nature welds her ring of ageless power, joining another cycle to the last, flinging the chain unto the end of time, the whole reflected in each separate part. Turn now thine eyes again, love, to the teeming profusion. See its bafflement dispelled. Each plant thee heralds now the iron laws. In rising voices, hear the flowers declaim, and, once deciphered, the eternal law opens to thee, no matter what the guise, slow caterpillar or quick butterfly. Let man himself the ordained image alter. Ah, think thou also how from sweet acquaintance the power of friendship grew within our hearts, to ripen at long last to fruitful love. Think how, think how our tender sentiments unfolding took now this form, now that, in swift succession. Rejoice, the light of day, love sanctified, strives for the highest fruit, to look at life in the same light, that lovers may together in harmony seek out the higher world. All right, the Metamorphosis of Plants. Introduction. 1. Anyone who has paid even a little attention to plant growth will readily see that certain external parts of the plant undergo frequent change and take on the shape of the adjacent parts, sometimes fully, sometimes more, and sometimes less. 2. Thus, for example, the single flower most often turns into a double one when petals develop instead of stamens and anthers. These petals are either identical in form and color to the other petals of the corolla, or still bear visible signs of their origin. 3. Hence, we may observe that the plant is capable of taking this sort of backward step, reversing the order of growth. This makes us all the more aware of nature's regular course. We will familiarize ourselves with the laws of metamorphosis by which nature produces one part through another, creating a great variety of forms through the modification of a single organ. 4. Researchers have been generally aware for some time that there is a hidden relationship among various external parts of the plant that develop one after the other and, as it were, one out of the other. For example, leaves, calyx, corolla, and stamens. They have even investigated the details. The process by which one and the same organ appears in a variety of forms has been called the metamorphosis of plants. This metamorphosis appears in three ways: regular, irregular, and accidental. 6. Regular. Metamorphosis may also be called progressive metamorphosis. It can be seen to work step by step from the first seed leaves to the last formation of the fruit. Image 1. By changing one form into another, it ascends, as on a spiritual ladder, to the pinnacle of nature, propagation through two genders. I have observed this carefully for several years, and now propose to explain it in the present essay. Hence, in the following discussion, we will consider only the annual plant that progresses continuously from seed to fruiting. 7. Irregular metamorphosis might also be called retrogressive metamorphosis. Image 2. So this is image 1 and image 2. When I showed image 1 before, I was accidental. That was actually figure 1, but this is image 1 and this is image 2. Irregular metamorphosis might also be called retrogressive metamorphosis. Image 2. In the previous case, nature pressed forward to her great goal, but here it takes one or more steps backward. There, with irresistible force and tremendous effort, nature formed the flowers and equipped them for works of love. Here it seems to grow slack, irresolutely, leaving its creation in an indeterminate, malleable state, often pleasing to the eye, but lacking in inner force and effect. Our observations of this metamorphosis will allow us to discover what is hidden in regular metamorphosis, to see clearly what we can only infer in regular metamorphosis. Thus, we hope to attain our goal in the most certain way. Under this plant right here, it says figure 1, and it says the annual plant, Goethe's basic model in his discussion of metamorphosis, plant parts, separated for the purpose of illustration from top to bottom, pistil, stamens, corolla, calyx, stem leaves, cotyledons, and roots. Eight. We will, however, leave aside the third metamorphosis, caused accidentally and from without, especially by insects. It could divert us from the simple path we have to follow and confuse our purpose. Opportunity may arise elsewhere to speak of these monstrous, but rather limited excrescences. I have ventured to develop the present essay without reference to illustrations, although they might seem necessary in some respects. I will reserve their publication until later. This is made easier by the fact that enough material remains for further elucidation and expansion of this short preliminary treatise. Then it will be unnecessary to proceed in the measured tread required by the present work. I will be able to refer to related matters, and several pages gleaned from like-minded writers will be included. In particular, I will be able to use comments from the contemporary masters who graced this noble science. It is to them that I present and dedicate these pages. 1. Of the seed leaves. 10. Since we intend to observe the successive steps in plant growth, we will begin by directing our attention to the plant as it develops from the seed. At this stage, we can easily and clearly recognize the parts belonging to it, its coverings, which we will not examine for the moment, are left more or less behind in the earth, and in many cases the root establishes itself in the soil before the first organs of its upper growth, already hidden under the seed sheath, emerge to meet the light. 11. These first organs are known as cotyledons. They have also been called seed lobes, nuclei, seed laps, and seed leaves in an attempt to characterize the various forms in which we find them. 12. They often appear unformed, filled with a crude material, and as thick as they are broad. Their vessels are unrecognizable and scarcely distinguishable from the substance of the whole. They have little resemblance to a leaf, and we could be misled into considering them separate organs. 13. In many plants, however, they are more like the leaf in form. They become flatter. Their coloration turns greener when they are exposed to light and air, and their vessels become more recognizable, more like the ribs of a leaf. 2. Under this, it says, under figure 2, it says, germination of the garden bean. Seed open, cotyledons separated to reveal embryo. 2. Bean in process of germination. 1. Cotyledon removed to reveal growing embryo, the latter now with strong root and radically increased in size. 3. Advanced stage of germination. 14. In the end, they appear as real leaves. Their vessels are capable of the finest development, and their resemblance to the latter and their resemblance to the later leaves prevents us from considering them separate organs. Instead, we recognize them as the first leaves of the stem. 14. In the end, they appear as real leaves. Their vessels are capable of the finest development, and their resemblance to the later leaves prevents us from considering them separate organs. Instead, we recognize them as the first leaves of the stem. 15. But a leaf is unthinkable without a node, and a node is unthinkable without an eye. Hence, we may infer that the point where the cotyledons are attached is the first true node of the plant. This is confirmed by those plants that produce new eyes directly under the wings of the cotyledons. 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 I'm going to say cotyledons. And develop full branches from these first nodes, as for example in the Vicia faba VICIAFABA. Image 3, broad bean seedling. VICIA space FABA. But a leaf is unthinkable without a node, and a node is unthinkable without an eye. Hence, we may infer that the point where the cotyledons are attached is the first true node of the plant. This is confirmed by those plants that produce new eyes directly under the wings of the cotyledons and develop full branches from these first nodes, as, for example, in the Fascia faba. Image 4, broad bean seedling, Fascia faba. (16) The cotyledons are usually double, and here we must make an observation that will become more important later. The leaves of this first node are often paired, whereas the later leaves of the stem alternate. That is, here parts are associated and joined, which nature later separates and scatters. Even more noteworthy is the appearance of the cotyledons as a collection of many small leaves around a single axis, and the gradual development of the stem from its center to produce the later leaves singly. This can be seen quite clearly in the growth of the various kinds of pines. Then it says image 5. And under image 5, it says the Australian black pine, the Pinus nigra. (16) The cotyledons are usually double, and here we must make an observation that will become more important later. The leaves of this first node are often paired, whereas the later leaves of the stem alternate. That is, here parts are associated and joined, which nature later separates and scatters. Even more noteworthy is the appearance of the cotyledons as a collection of many small leaves around a single axis, and the gradual development of the stem from its center to produce the later leaves singly. This can be seen quite clearly in the growth of the various kinds of pines. Image 5. Here, a circle of needles forms something like a calyx. We will have occasion to remember this when we come to similar phenomena. What's this? We will ignore for the moment the quite unformed individual nuclei of those plants that sprout with but a single leaf. 18. We will, however, note that even the most leaf-like cotyledons are always rather undeveloped in comparison to the later leaves of the stem. Their periphery is quite uniform, and we are as little able to detect traces of serration there as we are to find hairs on their surfaces or other vessels peculiar to more developed leaves. 2. Development of the stem leaves from node to node. 19. Now that the progressive effects of nature are fully visible, we can see the successive development of the leaves clearly. Often, one or more of the following leaves were already present in the seed, enclosed between the cotyledons. In their closed state, they are known as plumules. In different plants, their form varies in relation to that of the cotyledons and the later leaves. Most often, they differ from the cotyledons simply in being flat, delicate, and generally formed as true leaves. They turn completely green, lie on a visible node, and are undeniably related to the following stem leaves, although they usually lag behind in the development of their periphery, their edge, of their periphery, their edge. 20. But further development spreads inexorably from node to node through the leaf. The central rib lengthens, and the side ribs along it reach more or less to the edges. These various relationships between the ribs are the principal cause of the manifold leaf forms. The leaves now appear serrated, deeply notched, or composed of many small leaves, in which case they take the shape of small, perfect branches. The date palm presents a striking example of such successive and pronounced differentiation in the most simple leaf form. Image 6. In a sequence of several leaves, the central rib advances. The simple fan-like leaf is torn apart, divided, and a highly complex leaf is developed that rivals a branch. Let's look at image 6. Maybe pause and check out the card. But let's see what it says under image 6. Leaves of Mediterranean fan palm. The Chamaerops humilis. Chamaerops space humilis. Leaves of Mediterranean fan palm, showing successive differentiation in form from bottom to top. This is the species of palm that drew Goethe's attention at the botanical garden in Padua, Italy. Oh, 1 second. Okay. I'm going to read that that paragraph 20 again. But further development spreads inexorably from node to node through the leaf. The central rib lengthens, and the side ribs along it reach more or less to the edges. These various relationships between the ribs are the principal cause of the manifold leaf forms. The leaves now appear serrated, deeply notched, or composed of many small leaves, in which case they take the shape of small, perfect branches. The date palm presents a striking example of such successive and pronounced differentiation in the most simple leaf form. Image 6. In a sequence of several leaves, the central rib advances. The simple fan-like leaf is torn apart, divided, and a highly complex leaf is developed that rivals a branch. 21. The development of the leaf stalk keeps pace with that of the leaf itself, whether the leaf stalk is closely attached to the leaf or forms a separated, small, easily serrated stalk. 22. In various plants, we can see that this independent leaf stalk has a tendency to take on the form of a leaf. For example, in the orange family, image 7, its structure will give rise to certain later observations, but for the moment we will pass them by. This is image 7. Image 7, leaf of lime. Citrus aura and ornithifolia. Citrus ornithifolia. Leaf of lime with broadened petiole, which is a slender stem that supports a leaf. And once again, he says of this leaf of lime, in various plants, we can see that this independent leaf stalk has a tenacity. In various plants, we can see that this independent leaf stalk has a tendency to take on the form of a leaf. For example, in the orange family, which is image 7, its structure will give rise to certain later observations, but for the moment we will pass them by. 1 second, I'm going to kick my dogs out because they start shaking and stuff like that. Out. Oh, man. 23. Neither can we enter here into further consideration of the stipules, stipules. Neither can we enter here into further consideration of the stipules. We will simply note in passing that they share in the later transformation of the stalk, particularly when they form a part of it. 24. Although the leaves owe their initial nourishment mainly to the more or less modified watery parts that they draw from the stem, they are indebted to the light and air for the major part of their development and refinement. We found almost no structure and form, or only a coarse one, in those cotyledons produced within the closed seed, covering a bloated, as it were, with a crude sap. The leaves of underwater plants likewise show a coarser structure than those of plants exposed to the open air. In fact, a plant growing in low-lying, damp spots will even develop smoother and less refined leaves than it will when transplanted to higher areas, where it will produce rough, hairy, more finely detailed leaves. Images 8A and 8B. Let's take a look at those images. This is image 8A and 8B. Under those images, it says 2 varieties of colt's foot displaying intraspecies differences in leaf morphology at different elevations. The top one, Pedicites frigidus nivalis, from 5,000 foot elevation in the Cascade Mountains, And the bottom one, Pedicites frigidus variation palmatus, from 2,400-foot elevation in the Cascade foothills. That's the higher one, that's the lower one, respectively. So let's check out what he said again about those. Although the leaves owe their initial nourishment mainly to the more or less modified watery parts that they draw from the stem, they are indebted to the light and air for the major part of their development and refinement. We found almost no structure and form, or only a coarse one, in those cotyledons produced within the closed seed covering and bloated, as it were, with a crude sap. The leaves of underwater plants likewise show a coarser structure than those of plants exposed to the open air. In fact, a plant growing in low-lying damp spots will even develop smoother and less refined leaves than it will when transplanted to higher areas, where it will produce rough, hairy, more finely detailed leaves. Image 8A and 8B. 25. In the same way, more rarefied gases are very conducive to, if not entirely responsible for, the anastomosis of the vessels that start from the ribs, find one another with their ends, and form the leaf skin. In the same way, more rarefied gases are very conducive to, if not entirely responsible for, the anastomosis of the vessels that start from the ribs, find one with their ends, and form the leaf skin. That word is spelled Anastomosis. The leaves of many underwater plants are thread-like or assume the shape of antlers. We are inclined to ascribe this to an incomplete anastomosis. This is shown at a glance by the growth of Ranunculus aquaticus, where the leaves produced underwater consist of thread-like ribs, although those developed above water are fully anastomosed and form a connected surface. In fact, we can see the transition clearly in the half anastomosed, half thread like leaves found in this plant. Figures 3, 4. This is figures 3 and 4 right here. And under these, under the top one, under figure 3, water buttercup, Ranunculus aquaticus, displaying fully formed aerial leaves and thread-like submerged ones. Figure 4, floating leaves of water buttercup, representing transitions to submerged leaves. Experiments have shown that the leaves absorb different gases and combine them with the liquids they contain. There is little doubt that they also return these refined juices to the stem and thereby help greatly in the development of the nearby eyes. We have found convincing evidence for this in our analysis of gases developed from the leaves of several plants and even from the hollow stems. 27. In many plants, we find that one node arises from another. This is easy to see in stems closed from node to node, like the cereals, grasses, and reeds, but not so easy to see in other plants that are hollow throughout and filled with a pith, Pith, or rather, a cellular tissue. This substance, previously called pith, was considered to occupy an important position among the inner parts of the plant, but its importance has recently been disputed, and with good cause, in my opinion. Hedwig Leipzig Magazine, number 3, that's the source. Its supposed influence on growth has been flatly denied. The force of growth and reproduction is now ascribed wholly to the inner side of the second bark, the so-called liber, Liber. Since the upper node arises from the node below and receives sap from it, we can easily see that the node above must receive a sap which is finer and more filtered. It must benefit from the effect of the earlier leaves, take on a finer form, and offer its own leaves and eyes even finer juices. 28. As the coarser liquids are continually drawn off and the purer ones introduced, as the plant refines its form step by step, it reaches the point ordained by nature. We finally see the leaves in their maximum size and form, and soon note a new phenomenon that tells us that the previous stage is over and the next is at hand, the stage of the flower. Chapter 3. Transition to flowering. 29. The transition to flowering may occur quickly or slowly. In the latter case, we usually find that the stem leaves begin to grow smaller again and lose their various external divisions, although they expand somewhat at the base where they join the stem. At the same time, we see that the area from node to node on the stem grows more delicate and slender in form. It may even become noticeably longer. 30. It has been found that frequent nourishment hampers the flowering of a plant, whereas scant nourishment accelerates it. This is an even clearer indication of the effect of the stem leaves discussed above, as long as it remains necessary to draw off coarser juices. The potential organs of the plant must continue to develop as instruments for this need. With excessive nourishment, this process must be repeated over and over. Flowering is rendered impossible, as it were. When the plant is deprived of nourishment, nature can affect it more quickly and easily. The organs of the nodes are refined. The uncontaminated juices work with greater purity and strength. The transformation of the parts become possible, and the process takes place unhindered.